Good morning, good afternoon, everyone. Thank you for joining today's webinar. I'm Analia. I work for VAST Data as a campaigns manager. Thank you for joining us today. Welcome to this webinar. It's titled Unlock HPC Potential, Insights from NYU's HPC Advancements with VAST Data. I want to introduce to you our speakers today. Today we'll have Carl Evans. He's a senior HPC specialist at New York University. And we have Andy Pernsteiner, who's field CTO at VAST Data. Thank you both so much for being here today. I look forward to hearing your all's conversation. For questions, you all are welcome to ask your questions. We encourage you to do so by using the Q&A tab on the right-hand side of your screen. You just type your questions in there. We look forward to hearing them. If you want to ask anonymously, you can do so by just checking the box beside hide your name at the bottom of that panel. Without further ado, here's Andy and Carl.
Good morning or afternoon or evening, depending on where in the world you hail from. I'm welcoming Carl here with me, and actually Carl and I shared some time on a stage at Supercompute in Atlanta several weeks ago. And it was actually at that event that we launched a new feature set for our platform. And actually Carl's gotten a little time to test it out. But before we get into all of that, maybe Carl, if you could, I guess, explain a little bit about what your day-to-day role is at NYU and the types of environments or systems that you manage.
Sure, and good morning, everybody. So, Carl Evans, I'm a senior HPC specialist at NYU. I work as part of NYU IT, and our team covers research technology services for the entire university. That covers things like our HPC environment, and on-prem cloud, data lake, Gen AI stuff, basically anything to service the research community, whether you're a physicist or, in the social sciences. We kind of provide whatever services we can to help facilitate research for the university.
So then is it, I guess, accurate to say that researchers will come to you and ask for resources and you give that to them, and then, what are they usually doing? Are they, running jobs? Are they doing experiments? Like, what kinds of stuff do they get up to?
Yeah, so, it might be like some AlphaFold or some chemistry stuff, but, researcher, say they need some GPUs or something like that, they come to us and, we onboard them onto one of the environments. In this case, it's mostly going to be talking about the HPC side of the house. So we provision accounts for them on the cluster. We set them up with whatever accounting resources. Maybe they're a stakeholder, maybe they're just in the general education community. Maybe they're a student, yeah.
And
So basically,
then when you get them set up, I'm assuming since you manage an HPC farm, they get an account, they can launch jobs. Do they tell you what they're going to do before they run things?
very rarely. Most of the time, researchers, their workflows are pretty dynamic. They can change, on a daily basis. So we usually only hear from them if they're having a problem running some of their stuff, or if they're running into like some sort of like optimization bottleneck where, something is just taking too long. One of the things we occasionally hear is like, why is this slower on a fancy big HPC cluster than, my workstation and GPU?
Yeah.
And that kind of funnel into some of the profiling metric stuff that we're going to be talking about a little bit later in this chat.
Yeah, definitely.
A little bit more about, just a little bit more about the cluster. We've got basically 800 nodes, several hundred GPUs, various generations of GPUs from RTX 8000s, V100s, A100s, H100s, soon to be some H200s. A few AMD chips thrown in there just to make things like life a little spicier for us.
Nice. And then I guess, I assume that, you put this compute infrastructure together, you tie it all together. What kind of networking are you using on the HPC side?
So we've got both the most of the cluster, particularly like the storage I/O, is on InfiniBand fabric. Current cluster is using HDR. The next cluster is going to be NDR. But they also have Ethernet capabilities. So one of the things, we've got this hybrid environment where, we have our on-prem Kubernetes cluster. Maybe some users have some VMs or some services running there. Those will be talking back to the HPC cluster over Ethernet.
The mix of everything, I guess you would say.
Yeah, I think that basically sums up research technology at NYU. We do a bit of everything.
Yeah, I can imagine. Well, I guess what I'm going to do is I'll start to kind of talk through a little bit in terms of observability on our side, and at VAST, and maybe what I'll do is I'll just share my screen really quickly, and talk through a few things. And as I mentioned earlier, there's a new set of features that we kind of unveiled at Supercompute this past several weeks ago. But first, I'm going to talk about general sort of observability on VAST. I'm just going to share my screen, and I'm not going to do a full demo of everything. I'm just going to show a few things so everybody can kind of get a sense on how people monitor things on a VAST cluster. So I'm going to share my screen now, and basically right now I have a VAST cluster that's running our 5.1 release, which is actually one release behind. Sometimes I like things to be the latest and greatest, and sometimes I like to just leave things running the way they are and just see how things go. But in this case, I have a cluster. It's a relatively small one. It's got a couple hundred terabytes worth of all flash capacity, and it's got the ability to do up to around 40 to 50 gigabytes a second in bandwidth. And so right now, this is the main dashboard. And if I go through a few of the analytics pages, we have several different types of ways you can look at analytics on the VAST cluster. One of the ways is just looking at basic metrics in terms of bandwidth. And you can sort of go back to different points in time and say, okay, what's been going on for the last several hours? You can do a little drag and drop action to go and zoom in on the time point that you care about. There's a lot of predefined dashboards you can create, and then you can also create your own customized dashboards. I'm not going to go through all of that, but there's a lot of sort of ability to kind of create your own customizations here. All of this stuff is exportable using a REST API. We also have a Prometheus exporter to make it really easy for people who already have Grafana dashboards and that kind of thing set up. I guess a quick question, Carl, like, day to day, how do you guys normally monitor your VAST systems? Do you do the UI, or are you using something else?
So right now we're still mostly using the UI, and the dashboards you've been showcasing here so far have been super helpful for just that holistic cluster health performance. When you guys rolled in the data flow and top actors dashboards, that kind of got really cool.
Well, yeah. So you mentioned data flow, which is nice because then I can bring it up. And basically, data flow is a mechanism where we take a bunch of metrics that come from people who are accessing the system, and then we effectively track all of the endpoints that people are using, so that we can know who's doing what to which export, using which hosts, using which VAST C nodes and virtual IPs. So you get an end-to-end understanding. You can do some level of isolation to be able to identify, okay, well, this particular host or this person, I want to narrow in on it. And it's been pretty useful for a lot of people. Most of the things that we develop in our UI and in our sort of product in general are customer driven, meaning some customer asked for it. This one actually wasn't asked for by a customer. One of the engineering team leads had an idea and they ran with it, and it actually turned out to be pretty interesting. Just to sort of tie off, Carl also mentioned top actors, which is basically a scatter plot more or less to show you, who the top actor is, and you can isolate them again and then go and zoom in on their sort of on how they're using the system and get more insight into that individual user. That one's a little bit slow. My VPN might be a little bit slow. But the other thing that we added as well, and I won't go into a lot of detail, there's other webinars we've done related to capacity monitoring, is we also have real-time capacity dashboards that are updated in such a way that we can show you who's doing what on the system in terms of the amount of capacity. This is a lab system that doesn't really have a whole lot of real stuff going on, so there's not that much interesting stuff to see. But on a real system, you would see a lot more. Now, there is an aspect of all of this that I guess you could say is missing, though. So if you look at the analytics and the data flow side of things,
Yeah, I
You
was
have,
going to
the
mention that
user who
real quick.
did something.
I just
Yeah, go
wanted to
ahead.
say, yeah, no, this is great. But in our particular HPC cluster, we don't necessarily have a whole node for an individual user. So that user might have like 3 jobs on the same node or whatever. And so yeah, we're kind of missing a step of granularity down here. If one job is actually being the bottleneck, how do we like remediate that resource so the rest of the cluster health is remains performant?
Yeah. And that actually kind of brings up the thing that I'll start to walk people through a little bit, which is, you know, when you have a large HPC cluster and you have lots of users running things, and from your standpoint, it probably looks kind of random, right? It's not like the same users run a job every day at the same time, right? They could do anything they want.
Yeah, absolutely. And they do.
Yeah. I'm sure they do. And so I guess in order to kind of see what's going on, you need a little bit more inspection. And one of the challenges that we've had with the NFS protocol is that it doesn't really have space for extra information to be added. So you get obviously the normal IO statistics in terms of whether it's a read or a write. If it is, how large the read or write is, who the user is, the host it came from, the destination directory and that sort of thing. But you don't know the job information. And actually, speaking of jobs, what scheduler are you using?
So we're using Slurm, which I'm sure fair number of our audience probably is familiar with.
Yep, definitely. Okay, so I'm going to go through a few slides and kind of explain a little bit of detail around, I guess, what the features that we developed. I'm going to go through a little funny exercise just because it's fun to go through funny exercises. So the first thing is that what happens in your typical day? You get somebody, they call you up, and now usually do you feel like when a researcher reaches out to you and says, hey, something's wrong with my job, do you feel like they give you a lot of information to tell you what they're doing or tell you what they're seeing?
No, there's usually a fair amount of back and forth being like, okay, where's your submit script? What are you doing? And it usually takes a little bit of back and forth before we can actually get to the workflow that they're trying to run or having a problem with, so we can find out, okay, what node were you on? What's actually going on with that? Is it a code thing? Is it a system thing? None of that is really conveyed to us from the researcher's perspective most of the time.
And do they normally know what their job ID is that they launched?
I mean, some of the more experienced users who have been using Slurm for a while know how to pull that stuff up. Others don't. They're just like, I submitted this yesterday. I mean, the info SQ account stuff, it does present that information if we can tell them like, okay, what's the job ID? Here's a command that you can run to tell us what that one was. And
Definitely.
but
Okay, well, so what I'm going to do, I got to switch screens in a second because I have to launch a script to get some IO going. But before I do that, I'm gonna skip ahead a few slides because what we see a lot of times is that users don't know as much information as you probably need them to know, and so you have to do your own sort of hunting and pecking, right? You're gonna go and look at, you're gonna look on the scheduler side, you're gonna look on the VAST cluster side, you're gonna maybe go into some of the hosts that they're actually running things on and see what's happening, probably, right?
yep,
And so all those things. And so what we decided to do is, give me a second, I'll find I'll find what he did. So VAST has like a few different options for how you can get to the bottom of things. And the first of which is you can go into the UI and look at data flows and the other analytics that I showed you. We also have all of our audit records that are housed in a audit record database, which show you more granular statistics in real time. So you can see what files are being hit the hardest. And all of that is pushed into a database that lives on the VAST data platform. And so you can build Grafana dashboards on top of that as well. I might be able to show that in a minute. But we added something new. And we actually added something that isn't necessarily VAST specific, but I'm going to walk through it piece by piece here. So we created something we call the VNFS collector. That might not be the official name forever, but it's the official name right now. And it's basically an RPM package or Debian, depending on the type of OS that you're launching on. We've also created a daemon set for Kubernetes. So if you have a Kubernetes cluster, you can deploy a YAML file, which will then basically give this capability to all the pods that are running in a Kubernetes context. And I'll show you the way that it works. But basically, as an administrator, when you can install this RPM on your hosts, you can then go and set up a config file, which I'm going to show you an example of. And you can choose which environment variables that you want to track. Now, I guess, Carl, maybe I'll ask a question, which is, in your world, what kinds of environment variables would you want to track in terms of the I/O that's flowing through a system?
I mean, for the the job ID on the HPC side is key. Also, the UID number is great. Dropping in the username is even better, just because we went kind of full in on Prometheus and Grafana for our metric stack when we built out the current HPC cluster. But being able to tie those specific metrics back to a user and let a user be able to go in and view in a dashboard like some of their aggregate stats. So maybe I want to see my job history for everything that I ran. And getting that information tagged together in a sensible sort of way. Some exporters can do this, some exporters can't. Your guys' solution though is really nice, and there's a flexibility involved in that kind of lets the customer be able to track whatever sorts of environment variables they want, and with the combination of Slurm's prolog, epilog functionality, we can inject basically any environment variable that we want to for a user whenever they submit a job. They don't need to do anything in their own, submission scripts or anything to do that. We can kind of start putting some of those pieces in place together for them ahead of time that'll make aggregating this information a little bit easier at the end.
That's awesome. Yeah, I haven't had to manage HPC clusters. I've only had to support people who are managing them, and so I'm pretty excited to see how this kind of works its way out. Just to tie off on the rest of the stuff here, so basically, it's the RPM or Debian package contains an eBPF filter, which basically means there's a zero performance impact way for metrics to be collected. And the way that it works is that anytime an I/O on a client or on a host goes to an NFS mount point, then this filter picks it up and it gets the obvious information like whether it's a read or a write or some kind of metadata operation. It knows obviously the host that it came from and the destination mount point, but it allows for you to also specify the environment variables that are set when the process is launched. And as Carl was mentioning, he can set these things up on his side so that anytime a user launches any kind of a job, all the relevant environment variables are captured. And then all of this gets forwarded to a destination. All these metrics get forwarded to a destination from all of the clients. So you install the RPM on all your clients, and then you go and run everything like normal. And then you start to have metrics flowing in that are, sort of capturing all this information. And it goes to a number of different destinations. The one that is most commonly used from the people that I've been talking with is Prometheus, which allows for pretty easy building of Grafana dashboards. It can also go to a Kafka queue. So if you have Kafka in your environment and maybe you have a pipeline where you take any events that go to Kafka and you shove them into Elasticsearch or into some other sort of sync, you can use that as well. And we also, because we like to eat our own dog food, created a way for it to forward into a VAST database table. So VAST, if you didn't know, has its own database table format. And so this way we can have all the metrics sort of self-contained. And in the initial implementation that we've done right now, this is the way that it works. We will have a little bit more of an extension on it in the future. The one thing I'll point out at the bottom of the slide here is that we made this because our customers have been asking for it, but we didn't want to make it in such a way that you couldn't use it with any other platform. So any NFS server that you might be mounting, you can also collect these metrics for the I/O that goes to those servers. So it doesn't matter if it's a homegrown Linux NFS server that you're using and you're mounting, or one from another vendor. This collector will work for all of them. It's not very specific to any specific technology. And then coming soon, we're going to have a full integration into our VMS. So you'll actually see UI charts and dashboards. But why don't I go ahead and open up some config file related stuff, and then I'll launch a script to generate some I/O so you can see what actually happens. So I'll switch over to a terminal window real quick, and then while we're waiting, I'm going to go ahead and launch some I/O in the top window. But we won't pay attention to that. Instead, we'll look at the bottom window. And I'm going to go ahead and open up this YAML file. And the YAML file, actually, I'll open it up in VI, so maybe we get a little color in our life. So basically, this is a YAML file that when you install the RPM, you have to configure this YAML. It's got some defaults in there, but I'll talk through each of the individual ones. So at the top where it says envs, that's the list of environment variables that you want it to track. Now, in my case, I was lazy. I just called it job ID. What is it called in your world, Carl? I think for some reason you got muted, Carl. I'm not sure how. Right, one more time. Well, while we sort out the audio, it's okay. I can keep going. So basically, you specify whatever environment variables you want. I put in job ID, but there's some other ones that we thought might be useful as defaults. But obviously, you would choose whatever ones are most relevant to you. And then the interval is basically the number of seconds that it will send in terms of a polling interval, right? So it's not constantly sending these metrics every time there's a metric to send. It's collecting them up as counters based on the interval time frame. In this case, I'm using 5 seconds, so I know that it'll be more refreshed. But a lot of times doing something like 60 seconds or even a couple minutes is fine because you're not necessarily looking for right now data. It's okay if it's maybe a minute or two behind because usually if a user calls, you want to look at what has happened, not what's happening right that moment. Now, it has a bunch of different destinations. One of the destinations is it can go straight to a log file, which may not be that useful because you only get it on one client, but it might be useful in the case where you have some kind of method of forwarding all your logs to, let's say, Logstash using Filebeats or to Splunk using one of Splunk's forwarders. And so it's not that you need to set up a Kafka cluster or you need to set up a VAST database table or Prometheus. If you have Splunk or Elasticsearch or something like that already set up, you can probably use it. Since you're back, Carl, let's see if your audio works.
Yeah, hopefully that fixed that.
Oh, it does work. So I mentioned earlier that I use job ID. What do you use in your environment in terms of environment variables?
So that's slurm underscore job ID. Is
oh, there. Okay. Here, you know what? I'm going to put that in I'll put that in later as a comment. And so as I was explaining, you can have a destination being a local log file, and I'll show an example of what that looks like in a minute. And you obviously don't want to keep this stuff forever. So generally speaking, you'd want to have some kind of retention size amount. Now, another option is it can go to a VAST database table. And in this case, I specified a VAST database table on one of my VAST clusters. Normally you'd put in a DNS name here, but I think I didn't set up DNS in this environment. And then, there's documentation that we'll be releasing on how to set all this stuff up in case you are interested in using it. For Prometheus, it's just a matter of specifying the Prometheus exporter host and then a port, and then all those metrics get forwarded into there. And then the last one that I'm not using in this case because I didn't have a Kafka cluster set up in this environment is you can specify, the Kafka brokers and then a topic for it to send that data into. So there's a lot of different ways that you can interoperate with this. None of them actually require using VAST, but we made it. So we hope that you'll use VAST because, we made it. I'll show an example of what the log files look like, right? So I'm just going to tail the local log file on this host, and I'm going to pipe it through JQ just so you get some pretty colors again. Good to have colors. And so basically what you get is for each sort of, we'll call it, I'm not going to call it a tuple, but in this case, for each mount point, it shows you the name of the application. So in this case, it was just batch, but in the case of a real job, you'd probably see some other real process name here. And then it gives you counters for all the things that happen in the collection period. So we see all of these different NFS operation types. And each of those operation types will have a count as well as a duration, which helps you understand latency and that sort of thing. And then, of course, it gives you timestamp and host name, that sort of thing. And so you get these for each sort of combination. So now you see that the ls command was used against the mount point. And then you can see all of the sort of counts and errors and all of the different bits and pieces that might be interesting. And it's not easy to look at from a log perspective. So usually people would want to go in and set up some kind of monitoring and push out a Grafana dashboard, right? So I'll go ahead and jump over to a job ID dashboard that I created. And I'll hit the refresh button in a second to see if it actually works, because I just launched a script to load some data on there. But if you look here, I have a dashboard which shows the number of writes, and I've just sorted it in descending order. In this case, I have MATLAB, Python, TensorFlow, PyTorch, all running on a bunch of hosts that I kicked off against a VAST cluster. And then I have all the information related. So I know the process name in this case is generating the IO. I know the amount of IO per job ID. If I want to, I can filter by job ID or by user. So in this case, I'll go ahead and I'll filter by, I don't know, job ID. Let's just say, I'll type in 303 because I see that's sitting at the top there. And then it'll filter down. It'll show me just the stuff for that one job ID. Now, these are dashboards that I just started cooking up to make it easy for me to sort of demonstrate it. But you saw all the metrics that you can get there. You can come up with lots of interesting ways of looking at data so that you can narrow down who's doing what. So you can do it by job ID. You can also obviously do it by user. So I'll just go ahead and set all there, and then we'll just go ahead and filter. In this case, we'll do Madhu, because he seems like he's got a bunch of stuff he's doing right now. And then it'll go and filter everything down. You can see what processes Madhu is running, and you can see which job IDs are associated with Madhu's jobs, and how much IO he's doing, and how many records are in the database for him. So it's pretty flexible. And setting up the dashboards is relatively straightforward. We're actually going to be packaging them up and deploying them along with the RPM, Debian package, and Kubernetes YAML files. And so it's pretty easy to get started. In fact, Carl, I owe you some Grafana dashboards, so I'm going to get those to you later today or tomorrow.
That'd be fantastic. That's so cool
awesome.
that you're packaging that up, just because as an entry point, there's a ton of metrics in Prometheus and many ways displayed in Grafana. It's so helpful, like, when a new solution comes out there, give us a little, like, nudge in the right direction for how to get started, like actually visualizing some of this stuff.
Yeah, and we're always interested for feedback on how people would use it. In fact, in some ways, what I'd almost want to do on this webinar is ask the audience, what kinds of things would you do if you knew all of the job IDs and user IDs that were generating IO? Like, what would you use that for, and how would it be something that you would put into your day-to-day operation? So feel free to put things into the chat or ask questions. Carl and I could sit here and talk about our holiday plans while you guys decide if you want to ask questions.
It is that time of year.
It is that time of year. Someone asked if will the recording be later, and Analia responded, yes, we'll definitely put out the recording. There's also going to be a more recorded demo that we have that, sort of has all the elements of this to make it, I guess, more consumable. So you don't have to go through all of the explanation and back and forth. But, this is, and just for context, this feature is something that we released separate from the VAST product, right? This is an RPM, Debian, and Kubernetes packaged up application. But so James asks in the chat, is it available now? The answer is yes. If you are a VAST customer, then you can talk to your VAST support engineer or VAST sales engineer, or you could just email Andy at vastdata.com and I'll get it to you, right? We are going to be publishing it to open source. But we're waiting until a couple months go by so we can sort of do some more fine tuning of the way the config is set up and get some feedback from people who are testing it. You don't actually need to be a VAST customer to use it, but you need to contact somebody at VAST to get it. So if you aren't a VAST customer, just send an email to Andy at vastdata.com and say, I want me some VNFS collector bits, and I'll set you up. Let's see here. So Gavin asks, what are some of the surprise hurdles you had to clear deploying VAST in production, and how did you solve them? I guess that's more for you, Carl, than for me. So, if you wanted to share anything that you had, or it's up to you.
I mean, hurdles for VAST is kind of funny. Because as far as like HPC file systems go, there were actually no real bottleneck pain points for VAST. We kind of like first got our users onboarded using it. Like we didn't even get a chance to like really publish it as a new storage backend for us. It was just users were like running some particular workflows using like tons of small IO. And on our other file systems, they were just like not working. And, we just, as those research requests kind of came in, we're like, you want to just try it running on /VAST, which is the mount point for VAST on our cluster? And, they do that and boom, it works. It was just fine. As far as like, the racking and stacking the boxes of VAST and configuring it, like, the lovely VAST engineers help with all of that sort of stuff. And, it's up and running in basically no time. From
Are there
a managerial
things that
perspective,
I guess, because you'd been managing other storage platforms before, like mostly parallel file systems, right?
yeah. So, I mean, you're always in this bottleneck in the HPC world where, you've got your kernel version that you're approved to run. You've got it has to be in line with whatever MoFed version. It has to be in line with whatever like the storage vendor is providing, because all these pieces have to be like, verified, approved. You can't really deviate from any of those things. VAST doesn't really have that problem, even on like, to get the multi-endpoint support of the VAST client offers from our compute nodes. I mean, you guys provide the spec, we can recompile the RPM for whatever kernel version we're running. We've yet to, knock on wood, have run into a situation where like we made a problem for ourselves with it.
Yeah, and I guess just for context, for the people who don't know, what you're talking about is so VAST exposes standard protocols such as NFS, both version 3 and 4.1, as well as the SMB Windows File Sharing Protocol, as well as the S3 API. For NFS, we found that in order to overcome some performance bottlenecks on the sort of NFS client code side, we decided to go do the work of allowing NFS to parallelize a single mount point across many different servers that are servicing the same data set. And we kind of piggybacked on top of something that's in the Linux 5.3 kernel, which is called NConnect, which allows for parallel connections from the same client to the same server. But now we've extended it using something we call multipath, which will then go to multiple remote hosts. And so you can get a single mount point that spans an entire VAST cluster. This has actually been upstreamed into the Linux kernel, and I think it's in Red Hat 9 variants above a certain number. I have to double check. And so, what Carl was mentioning is that there is a RPM or Debian package that you can install from us that will enable this functionality, even if you're on an older version of the Linux kernel. It's not necessary to use because you can still use VAST using NFS without it, but you might get some benefit in terms of parallelization and distribution across the cluster if you do enable it. And as he mentioned, like we provide the source code for it. So if for some reason you need to recompile it against a specific version of a kernel, it's not a big deal. But if you do have a new enough kernel, you might not even need it because a lot of that stuff is already rolled in from the Linux community standpoint. And we're likely going to be also, seeing about extending further in terms of what we push into the kernel. One thing I'll mention about the VNFS collector. So phase 1 is just collecting the stats and being able to push them to these endpoints that we mentioned. We're going to open source that. It's really lightweight, relatively simple to set up. I got it set up in like less than 5 minutes on all my hosts. But there's another phase to it. Because there's actually a piece missing from what I'm showing you here, which is even though we have the job ID associated with all the IOs, Gregory wants me to set the refresh to every few minutes. Okay, you know what? Let me set it to every.
While you're doing that, Andy, you mentioned S3, and I guess that could be considered a hurdle for us. Initially in order to get, per user S3 buckets kind of provisioned on VAST for some of our users, we kind of went the API route to, create a little Python app that, goes and creates a new view or, an endpoint basically for our users to use. And that has actually worked pretty well. We haven't quite, packaged that up into be like a self-service functionality yet, or, built it into our account provisioning pipeline to auto-generate those things for our users yet. But
Gotcha.
I finally noticed that you guys actually also have like a Terraform provider that I've started to poke around with that can, kind of help out with that creation of the views for buckets, and as well as, the bucket policies to go alongside it.
Yeah, actually, my one of the people on my team, came up with that, and I realized my dashboard broke because I think my VPN connection got messed up. There's no metrics showing up, even though they were there a minute ago. So apologies for the dashboard, Gregory. I'll send you the RPM and you can set it up for yourself. What I was going to say is that there is something missing from this, which is that even though we have the IO statistics and we have the job ID, it's the VAST NFS server, and the VAST internal server code doesn't know anything about it. It's going to a separate destination. In this case, it's going to into Prometheus, and then there's Grafana dashboards built on top. But it doesn't give us the ability on the VAST side to be able to do anything in terms of quality of service based on job ID or being able to tie things together like that. And there are some of our customers who've asked us for the ability to do job ID specific quality of service. I'll switch dashboards so it doesn't show you something broken. But the way that we're going to do it is basically we're going to be extending our products to be able to look for specific fields in the NFS 4.1 payload. So NFS 3 doesn't really give us any place that we can put environment variables when the IO flows from the client to the server. But NFS 4 has some fields that are more or less unused that we can overload with key value pairs. And so then that way, what we'll do is we'll set up the VNFS collector to optionally, when someone's using NFS 4.1, to embed the metrics and the job ID information into the actual request payload for the NFS 4 request in such a way that when our NFS server receives that payload, the NFS server itself knows the job ID associated with every IO, because that's where we apply quality of service. So the VAST cluster does also support quality of service, which basically quality of service policies let you set high and low watermarks based on the amount of IO you want specific entities to be able to perform. And for the most part, the way that people use them today is they associate them with a view, which is basically an NFS export or an S3 bucket, or they associate them with a user. But there's no way to associate it yet with a job. And so that's the next iteration that we're going to do. It's going to come out sometime towards the end of next year. But it's, we're just trying to sort of march down the path of collect all the information and then allow you to action on it, and then start allowing automated action on it. So we're excited about that too.
Cool.
But stay tuned, it'll be there. Another thing that I didn't mention, and I probably have some screenshots laying around, but not right in front of me, is that the Grafana dashboards that I built are nifty, but we also have in our VAST 5.3 release, we have auto-created dashboards within our VMS management console that will have the job ID information as well. In the case that you're using a VAST database table to push those metrics into. So we'll have some, pre-built table sets that are set up on the VAST cluster. If you point your clients to shove their metrics into a VAST database table, we'll auto-generate graphs that are in our UI that you don't have to go set up a separate Grafana instance to manage. But that's coming in 5.3, which comes out in a couple months. So not in time for Christmas, unfortunately. But if you want the VNFS collector bits now, I can get you them in time for your favorite December holiday. Awesome. Anything you wanted to add? Oh, let's see here. Peter says, can you send VNFS data to multiple endpoints at the same time? Yes, actually, in my case, I'm sending it to local log files that I showed you using JQ. I'm sending it to a VAST database table, and I'm sending it to Prometheus. You can send it to also Kafka and all of them at the same time. I haven't tested doing all of them at the same time, but it does functionally work. Engineering gave me the bits and said they tested it, so it does work. I haven't
I've only tested on the 2 so far. I've
what
only done
was the 2
Prometheus
that
and
you
local
tested?
style as well.
Oh, okay.
Prometheus and local, but
That makes
I
sense.
was going to send it to Kafka too. I just haven't gotten around to it yet.
Do you have like a Kafka pipeline to shove stuff into Elasticsearch, or what were you gonna do with it?
I was just going to print it out on a console until I figure out something to, what I want to trigger off of it, where I want to send it.
Yeah. Cool. Yeah, I am curious what people end up doing when they push it to Kafka, just because we're going to start using Kafka for a lot more things to generate triggers and events for pipelines. So I'm curious how people might use that. So
And there might be some transforms that go through there. I mean, depending on for like how long do we need all of these metrics versus like what are the key ones that we actually want to like push into like the longer term storage for the users to be able to use. So I mean, there's some flexibility there with shoving it through Kafka, doing a little work with it, and redirecting it somewhere else.
for sure. Yeah, my next thing that I want to test in my environment is I got a bunch of Kubernetes pods running an AI sort of Gen AI application. I want to see what the metrics look like there. I just haven't set it up yet, but I'll probably do that later this week.
Got to resuscitate my dev cluster so we can do some of that too.
Yeah, nice. Well, I think we're just about wrapped up. Annalie, I don't know if you wanted to close things out or if you want me to, but I think we got a decent, lively discussion going today.
Yeah, thank you both for being here. You all answered all of the questions. So if anybody else has any more questions, feel free to reach out to hello@vastdata or Andy@vastdata. You could do either. If you want to explore more, feel free to join our weekly live demos on Tuesdays and Thursdays. You can find those at vastdata.com/demo. Again,
Yeah.
Carl, thank you so much for being here. Andy, thank you so much for being here.
Thank you. Thanks, everybody. Have a great rest of your week.